yesterday we talked about a rate of change. The day before we talked about slope. Today we're going to kind of pull everything together. So it says you have seen a linear function. The rate of change is constant and equal to the slope. That's all we talked about yesterday, that the rate of change is the same thing as the slope. This is because linear functions increase or decrease by equal differences over equal intervals. So if we look at the graph below, it says over the interval 2 to 4, so that means from the x's 2 to 4, how much does the function increase? So how much does the y increase?
1.
1. So if we look from this point to this point, from 2 to 4, the y's increase by 1. So the function increases by 1. From what to what? From 4 to 5. Over the interval 8 to 10, so again we're looking at the x's, 8 and 10. How much does the function, how much does the y increase?
1.
1. So the function increases by 1. From 7 to 8. So in order for this to be a straight line, the slope between these 2 points need to be what? If the slope between these 2 points needs to be the what as the slope between these 2 points? The same. If it is a straight line, that means whatever the slope is here needs to be the same as the slope here, which is what this is saying. It's saying from the interval 2 to 4, it went up by 1. And from 8 to 10, it also went up 1. So it's going to have the same slope. It's still rise up 1, run over 2. Rise up 1, run over 2. That makes it a straight line. So yesterday we kind of looked at one of the tables. There was a table yesterday that asked you to determine whether or not it had the same rate of change between points. So this one says, first they want us to determine the rate of change between negative 862 and negative 634. So we can do one of two things. We can plug this into the slope formula, or we can just look at these 2 points on the table and figure out what is the change between 62 to 34. Negative what?
Wait, let me do the math. Negative 28.
Negative 28. And for these same 2 ordered pairs, what's the change in x's?
Positive 2.
A positive 2. So to find the slope or the rate of change, remember that it is the change in y over the change in x. It's the change in y over the change in x. And if you can't remember if y or x goes on top, think about rise over 1, run, and y's rhymes with rise. So y's always go on top. So negative 28 over 2 gives me what? Negative 14. So the rate of change between these 2 points, we came up with negative 28 over 2, which reduces to negative 14, is the rate of change between those 2 points. Now they want us to look at these 2 points, negative 1, and 1, negative 1. So between negative 1 to negative 1, what is the rate of change? What is the difference?
0.
0. From negative 1 to 1, what is the rate of change?
Plus 2.
Plus 2. So again, we set this up as a ratio of change in y's over change in x, so 0 over 2, which equals 0. If you don't remember, look up here. 0 over a number is okay. It is equal to 0. Is this a linear function? That's asking, does it make a straight line?
No.
No. Why not?
Because it's not constant.
The slopes are not the same, or it does not have a constant rate of change. You can put either of those. Determine the slope of the line shown. So for this first one, if I start here, and my next point is going to be here. So how do I find the slope whenever I'm looking at a graph?
Rise over run.
Rise over run. So what is the rise to get from this point to this point?
Rise is 1 and run is 5. No, 4.
And so the rise was 1 and the run is
4.
4. So the slope for this line is 1/4. All right, the second graph. So let's start here and end here. Nope. So what is my rise going to be for that one?
4.
1, 2, 3, 4. And what is my run going to be?
2.
2. So that reduces to just positive 2.
Wait. How is it 4? Wouldn't it be 2? The rise is 2. Yeah.
I picked this point and this point. So I went up 4 and over 2. But it doesn't matter because it's still going to reduce to 2, no matter which 2 points you choose. So if you chose closer points, you didn't have to reduce your fraction.
Oh, okay.
Okay, and then the last one. So what is...
Landon and Aldrich Ross to check out, please.
He's on his way. So if I pick these 2 points, what is my rise?
4. Wait, which 2 points? Yeah,
This
4.
point and this point.
Oh, 5.
5, and what is the run?
1.
1, so that reduces to
1 over 5. 5 over 1.
5 over 1, so that's just 5. Alright, so describe the slope of any line that rises as you view it from left to right. So what happens when you're looking, what is the slope going to look like if it's rising? What does the number look like?
Positive.
It's going to be a positive number. So if the slope rises from left to right, it is going to be a positive slope. And so any line that rises as you read from left to right, just like you read words in a book, we read from left to right. Just the graphs are just the same. So it's going up, that's going to have a positive slope. On the next page, 5A. For this first line, let's pick this point and this point. What is the rise going to be? Okay, why is it negative?
Because it's going down.
It's going down. We start on the left point because we read from left to right. So if I'm trying to get from this point to this point, I went down 3. And then how far over did we run? 1. So that slope is negative 3. For this next line, let's pick this point and this point. How far do I have to go up or down? What's my rise? This point and this point. Negative 2. And then how far did I run over? 1. So that's negative 2. And then the last one, make those 2 points. So what is my rise here? Negative 3. And what is my run? 4. Positive 4. The run is always positive because you are always reading from left to right. But the rise can be positive or negative. That's what determines what the slope does.
So if the rise is going down, it would be a negative.
Right. So describe the slope of any line that falls as you view it from left to right. It will always be what? Negative. The slope will always be negative. So that looks like this. It's falling as you read from left to right. All right, 6A. I'm going to pick this point and this point. How far do I need to rise to get to the next point? 0. And then how far do I need to run? 3. So what is 0 divided by 3?
Unidentified.
Unidentified.
Look at the board.
0.
0. 0 on top is okay, and that is 0. All right, the next one. Pick any 2 points. I'm going to pick this one and this one. How far up do I need to rise?
0.
0. And how far did I run? Which reduces to
0.
0. I'm going to pick this point and this point. How far did I need to rise?
0.
0. How far did I run?
1.
Which is
0.
0. So the slope of every horizontal line is
0.
0.
0.
Which brings me to the next set of posters underneath the okay and the no. You see Vux and you see Hoy. Hoy, the H in Hoy stands for horizontal, and the O in Hoy stands for 0 because all horizontal lines have a 0 slope. And we will get to what the Y means a few more lessons from now. So Hoy is all horizontal lines have a 0 slope. Now, 7A. So let's pick 2 points. How far did I rise between those 2 points?
3.
Well, it was 2, but close. And how far did I have to run?
0.
So what is that?
Unidentified.
Undefined.
Oh.
So anything over 0 is going to be undefined. All right, the next one, if I start here and go up here, how far did I rise? 3. How far did I run?
0.
Which is
Undefined.
undefined. And the last one, what is the last one going to be? We're going to rise however many, and then we're going to run how much? 0. So this is still going to be undefined. So what is the slope of all vertical lines? So Vux, vertical lines are undefined slope. So on the top of the next page, they just have a handy dandy little chart for you. From going up from left to right would be what kind of slope?
Positive.
Positive. It's going up. Going down from left to right,
Negative.
negative. Horizontal,
0.
0. Vertical,
Undefined.
undefined. All right, take a few minutes, check your understanding. Suppose you're given several points, and without graphing, we want to find out if it's a linear, a straight line. How would we do that? Jordan.
Can I?
Constant what? Ahmed.
Find if it's linear, if it's a straight line.
Sean.
Oh, if it's a straight.
Find the slope or the constant rate of change. So because we can't, it says without graphing, so you're trying to find out if it makes a straight line without the graph. So you just have some points, so you need to find the slope or the constant rate of change. How can you tell from a graph if it's going to be positive or negative, Destiny?
If the line goes up from left to right, it's positive, and if it goes down from left to right, it's negative.
That's right. Up is going to be positive, and if it goes down from left to right, it's going to be negative. Describe a line having an undefined slope. What kind of line has undefined slope, Faith?
Straight up and down.
A straight up, so a vertical line, straight up and down. And why?
Oh.
Zaina? So what's always going to be 0? What is the bottom number? The run. So the run is always 0. All right, take a few more minutes and do 12 through 14. 12. Well, it says sketch a line for a line that has a positive slope. So what will that look like? It's going to be going up. What about one that has a negative slope?
Going down.
Going down. And a slope of 0. Hoi, it's horizontal.
So Hoy makes sense, but then Fox.
Vertical is undefined.
BUX Fox.
So I don't understand.
Yeah, I heard.
You heard Fox.
Why does Hoi make sense in Bucks?
Hoy makes sense because it's a pirate, but then Fox.
Alright, number 13.
Oh, Fox.
Does this table represent a linear function? So to test that, you need to see if the change in y over the change in x is the same as another change in y and change in x. So what is the change between -1 and 9? You're adding 10. What about between 1 and 4? You are adding 3. So 10 over 3, which we're not going to change to a mixed number. We just leave it like that.
Oh.
So 10 over 3. Now let's check this one. 19 to 29 is 10. And how much is 7 to 11?
4.
4. So 10 over 4. Are these the same?
No.
So is it a straight line?
No.
No, because it doesn't have a constant rate of change. All right, 14. There are two ways that you can go about number 14. You can either find the slope using the slope formula, or my preference would be to turn these numbers into a table and then do exactly what we just did with the other tables. So this would be 12, 11, 2, 7, 5, 9, and 1, 5. So what's the difference between 11 and 7? Minus 4. From 12 to 2. Minus 10. So a negative 4 over a negative 10 simplifies to positive 2 over 5. A negative over a negative simplifies to a positive. And then let's do these last 2 points. From 9 to 5 is what? Minus 4. From 5 to 1 is minus 4. So now I have negative 4 over negative 4, which is 1. So are those the same?
No.
So is it a straight line? No. So no, it doesn't have a constant rate of change.
Isn't it usually like you go from 12 to 2, but then you go to 2 to 5, then 5 to 1? Isn't that how we used to do it?
I'm sorry.
Huh?
12 to 2 and then what?
Then 2 to 5. Like we keep doing them.
All that matters is that the ratio between the change in y's over the change in x is the same. It doesn't matter which 2 points you choose. All right, turn to page 138. And we are going to do 13, 14, and 15. For number 13, is this a straight line? Is it linear?
No.
No. So how did you figure that out?
We find the ratio.
The ratio of change in y to change in x. So from 44 to 4 is minus 40. From negative 3 to negative 1, you're adding 2. So negative 40 over positive 2 reduces to negative 20. And then pick another 2 points. So if I chose negative 1 to 4, I am now adding 5. And 0 to 1 is adding 1. So I have 5 over 1, which reduces to 5. So no, that definitely does not make a straight line. Yes?
So like if there's like a table like this one, it's like 1 is plus 2, 1 is plus 4, and then it keeps going like that. Would that be?
The ratio between the change in y over the change in x needs to stay the same. So you can skip numbers, but all that really matters is when you divide the change in y over the change in x, you get the same thing. All right, 14, is this one a straight line?
Yes.
Yes.
Uh-huh.
Between negative 7 to negative 8, you are subtracting 1. Negative 5 to 0, you are adding 5. Negative 9 to negative 10, you are subtracting 1. 5 to 10, you are adding 5. So both of those, the rate of change is negative 1 over 5. And in the last table, is this one a straight line?
No.
It is. So negative 30 to negative 46, you subtract 16. 4 to 6, you add 2. So negative 16 over positive 2 is negative 8. And then here, negative 62 to negative 70, you are subtracting 8. 8 to 9, you are adding 1. So negative 8 over 1 reduces to negative 8. So they are the same.